Hi all, welcome to another Continuance of Nature devlog. In this devlog I'll only be talking about clouds as we took quite a lot of time to get done. I knew clouds may take some time, but I secretly hoped I'll be able to finish them in a couple of days. Of course that didn't happen. So I started by searching for easily usable volumetric cloud system that would work on Unity's universal render pipeline. But why do you want volumetric clouds? Wouldn't they just kill performance and not match the style of your game at all? But all the cool kids are doing volumetric clouds. But you're neither kid nor cool. You know what? You're right. I don't need to do something just because it's popular. I will use non-volumetric clouds. Well, wow, I didn't expect that. Wait a minute, did you only agree to use non-volumetric clouds because you're too stupid to make them yourself and couldn't find any easy implementation done by someone else that would work with Unity's universal render pipeline? What? No, why would you think that? So, after not finding anything easy enough on both performance and my brain cell, I decided that I don't need volumetric clouds for now. So I went to Unity's asset store to search for any clouds assets. After searching in Unity's asset store for a bit, I decided to go with Clouds Toy by Julian Alaidon. I chose this asset because I needed clouds to be 3D, so the player could go through them as my game will have freely controllable spaceships and similar stuff. This asset uses Unity's Shuriken particle system to generate clouds and then controls their movements in the sky. One huge issue with it was that it did not provide source code, only precompiled DLL. Additionally, of course it only supported flat planes and I'm creating spherical planets. So to go around both of these issues, I tried basically copying particle system it generates for each cloud and create my own clouds using that. However, this did not work. It seemed that Clouds Toy script was doing something internally to make it work. Second attempt was to simply let Clouds Toy to generate clouds for me and then remove Clouds Toy and manage them myself. This was quite a stupid idea, not gonna lie. After quick checking, it seemed that it should be possible, however if I disable and re-enable Cloud Game Object, it no longer works. This was an issue because I would have to keep all clouds active all the time and that would be a massive waste of performance. Especially as I want to have multiple planets and I definitely don't need planets that are thousands of kilometers away to have active clouds. To solve these issues, I needed access to source code of Clouds Toy. Luckily there's a paid version of this asset that actually provides a source code. Even though my game budget is €0, I bought the asset and now my budget is negative €5.4, taxes included. So first thing I do when working with some code I've never seen before is refactoring. Refactoring helps to familiarize with code and understand it a bit better. While refactoring I strip down everything I don't need, then I remove everything I don't understand, and we're good to start the actual work. Refactoring Clouds Toy took some time. It had quite a lot of a bit confusingly named variables and functions, comments that explain variables by basically rephrasing their names and so on. Despite that, after 3 or 4 hours I had quite clean code files that I could now understand and start working on. So first we want to make clouds to spawn around the planet instead of flat plane. To do that, we basically take a random location on Unisphere and multiply it by arbitrary number of our choosing, which represents the cloud's distance from the planet. So the farther away the cloud is, the bigger the number. Oh, okay, that was obvious. To get a random location on Unisphere, we basically just use Unity's built-in random implementation, which has a function called random Unisphere point. Whatever. To do that, we basically take random location on Unisphere, we do that by using Unity's built-in method, and multiply it by arbitrary number of our choosing, which represents the cloud's distance from planet. Then we simply rotate each of them to face planet by using Unity's lookat method and adjusting the angle by 90 degrees on x-axis. We do that because Unity's lookat method is actually making object to face point we want on z-axis while we want y-axis, I think. Not 100% sure if that's correct, but just read some random text I will put as correction on the screen, okay? This makes our clouds to spawn in a sphere around an imaginary point. So next we want to make our clouds to move around the planet. To do that, we simply create a few empty game objects at the core of the planet and assign each cloud to one of them. To decide which cloud is assigned to which object, we group them by their size and assign each size group to a different parent. Now we can simply rotate each parent at our chosen speed and boom! Clouds move around the planet at different speeds based on their size. Simple as that. That actually was very simple. I didn't even expect it to be so simple. I should not sing, because I have no voice. Adding these clouds to an actual planet created some issues. They seem to be rendered over the planet. Fixing this only took a few minutes though. It was caused by them being rendered by main camera overlay and not planet camera. And at this point we have pretty nice clouds that perform pretty well, however they still do not react to lighting. As making them react to actual light in real time could potentially be quite painful for game performance, I decided to simply change their color based on their position relative to the light. So we take normalized direction at which direction light is pointing, then take normalized direction from planet core to the cloud and get a dot product between them. Then we use this dot product to sample colors gradient and decide what color we want our clouds to be. The idea here is actually pretty similar to what we did when assigning ground textures by steepness. Wow, and this works? No, why would you think that, lol? For some reason clouds pass from one color to another pretty quickly, while they should be gradually changing color while moving around the planet. I thought the issue was caused by me forgetting to normalize direction from planet core to the cloud, but doing that made clouds to always be dark color as if they were always at the night side of the planet. After a bit of investigation, this issue turned out to be caused by a small mistake in my remap method, where I added from max instead of to min value. Wait, didn't you basically copy this method from Unity's forums? Yeah, so what? Gotta be pretty stupid to not even be able to copy code without mistakes, lol. Maybe I am stupid. Now it kinda works, however it seems that clouds color are a bit off. Clouds that should already use light day color are still using darker night color and vice versa. Almost like the direction of sun is incorrect. Interestingly, setting sun's rotation to 000 makes all clouds to use day color. The issue turned out to be pretty simple. I thought I can get a direction at which sun is pointing by simply normalizing sun's rotation. However, this was not the case. I should have simply used transform forward to get a direction. That's what happens when you decide to think for yourself instead of DuckDuckGoing. Why can't you just be normal and use Google? Turns into duck? Did you just say turns into duck? This works now, however the performance is not great, main performance killer being constant colors update. Before this point I had hopes to update each particle individually. This would allow us to have clouds that pass from one color to another in parts. However, as it obviously won't be happening due to performance issues, I decided to update colors only every tenth of a second. Also, I found a nice suggestion by mgear in Unity forums, pre-calculating gradient values and caching them. This way we don't need to evaluate gradient every time for every cloud and we can instead just take closest cached values. To search cached values we will use binary search algorithm. If we have 100 cached values, this should let us get closest value in just 6-7 iterations instead of 50 on average. By doing this I was able to make my code even slower than previously. That was exactly what I wanted. Moving on. Turned out searching cached values by using binary search was a very dumb decision. What I should have done instead is, if we have 100 cached values, simply take the color key value we need, multiply it by 100 and cast to integer. This will give us index of color key in cached color array. Simple as that. So after this was done, I made it so each cloud would save its previous time value, then if its current time value minus its held time value is lower than cached value increment, do not update cloud's color and do not repaint it as it should not have changed. So now we have a bit better performance, yet we still need some kind of LOD system. So to get at least some kind of LODs, we simply change number of particles emitted based on the cloud's distance from the player. To make it less visible, we increase the size of the particles. And of course, if cloud is far away, we simply disable it altogether. And boom, it looks amazing. After doing this, frame rate increased from about 100 to about 130 frames per second. This is still not great, however I decided to leave it as is for now. So this is it for this video. In the next devlog I will be either tackling game mechanics, as I've been postponing them for quite a while, or optimization, as in full scale optimization for plans to bring the game back to 200 plus frames per second, and get rid of frame rate drops when digging the terrain, because those are actually pretty bad, not gonna lie. I'm not sure which of these I'm going to do yet, likely both at the same time, but that would be a very horrible decision, so hopefully not. Also, I may not be able to release next devlog in 2 weeks, as there's quite a lot of small things I want to take care of before continuing the development. So thank you for watching and see you in the next devlog.